Have you ever gazed up at a plane soaring through the sky and wondered what incredible power propels it forward? The answer lies in one of the most brilliant inventions of the 20th century, the jet engine. These marvels of engineering are the heart of modern aviation, enabling us to travel across continents and oceans with astonishing speed. Today, we're going to demystify this powerful machine, breaking down exactly how a jet engine generates the massive force, known as thrust, that pushes an aircraft through the air. At its core, a jet engine operates on a very simple and elegant principle, Newton's third law of motion. For every action, there is an equal and opposite reaction. Imagine blowing up a balloon and then letting it go. The air rushes out the back, and the balloon shoots forward in the opposite direction. A jet engine works in much the same way, but on a vastly more powerful and controlled scale. It takes in air from the front, accelerates it, and expels it at extremely high speed out the back. This backward expulsion of gas creates an equal and opposite force that pushes the engine, and the entire aircraft, forward. To understand how this happens, we need to look inside the engine. A modern jet engine, specifically a turbojet or a turbofan, can be broken down into 5 main sections, each with a crucial role to play. Think of it as a production line for creating thrust. First is the air intake, followed by the compressor, the combustion chamber, the turbine, and finally, the exhaust nozzle. This sequence is often summarized with a simple mantra: suck, squeeze, bang, blow. Let's explore each stage of this powerful process. Our journey begins at the very front of the engine with the air intake. Its design is critical. The intake's job is to efficiently capture the incoming air and guide it smoothly into the engine. At subsonic speeds, the intake is typically a simple forward-facing duct. However, for supersonic aircraft, the intake's geometry becomes much more complex. Designed to slow the incoming supersonic air down to subsonic speeds before it reaches the compressor. A smooth, undisturbed flow of air is essential for the engine to operate efficiently and stably. The intake is the gatekeeper, ensuring the engine gets the air it needs to breathe. Once the air passes through the intake, it enters the compressor. This section is made up of a series of rotating blades, called rotors, and stationary blades, called stators. As the air moves through the compressor, each set of blades squeezes it, progressively increasing its pressure and, as a result, its temperature. You can think of it like a multi-stage bicycle pump. By the time the air leaves the compressor, its pressure can be more than 40 times greater than when it entered. This highly compressed air is now packed with potential energy, primed and ready for the next, most energetic stage of the process. Now we arrive at the heart of the engine, the combustion chamber. Here, the highly compressed, hot air from the compressor is mixed with a fine spray of jet fuel from a series of fuel injectors. This potent fuel-air mixture is then ignited by an igniter, similar to a spark plug in a car. This creates a continuous, controlled explosion. The temperature inside the combustion chamber can soar to over 2000 degrees Celsius. This intense heat causes the gases to expand dramatically and rush out of the chamber at an incredible speed. Heading towards the next section, as these super-hot high-pressure gases exit the combustion chamber, they slam into the turbine. The turbine looks a lot like a windmill, with multiple rows of precisely shaped blades. Its one and only job is to extract energy from the fast-moving gases. As the gases flow over the turbine blades, they cause the turbine to spin at an extremely high speed. Now, here's the genius part. The turbine is connected to the compressor at the front by a central shaft. So, as the turbine spins, it drives the compressor, which in turn sucks in and compresses more air. This creates a self-sustaining cycle. The turbine extracts just enough energy to keep the whole system running. Finally, the hot gases, having passed through the turbine, still have a tremendous amount of energy. They now race towards the final section, the exhaust nozzle. The nozzle is a specially shaped duct at the rear of the engine that narrows to a smaller opening. This constriction forces the exiting gases to accelerate to an even higher velocity, sometimes faster than the speed of sound. According to Newton's third law, this violent, high-speed expulsion of gas out the back creates the powerful, continuous forward thrust that propels the aircraft. So, to recap the entire amazing process, air is sucked in through the intake. The compressor squeezes it to high pressure. In the combustion chamber, fuel is added and ignited, creating hot, expanding gases. These gases spin the turbine, which powers the compressor. Finally, the gases are blasted out the exhaust nozzle at high speed, generating the immense thrust that makes flight possible. From a simple principle comes an extraordinary machine that has truly connected our world. Thank you for joining us on this journey inside a jet engine. If you found this explanation fascinating, please consider liking this video and subscribing to our channel for more deep dives into the world of science and engineering. See you next time.